Now that we know how to solve a quadratic equation by looking at a graph, and we can identify the characteristics of a quadratic graph, we need to learn how to solve a quadratic equation using algebra, and we're going to use a process called factoring to do that with. So what is factoring? It is actually finding the multipliers. And you know how we learned how to multiply polynomials? Well, the things that you multiply together are your factors. So in this case, 5 times 8 is going to give me 40. So that means 5 and 8 are factors of 40. They're the multipliers that give me 40. Now I've got a monomial and a trinomial here. And if I multiplied those together, I would get 12x to the third plus 8x squared minus 28x. That means that my 4x and my trinomial, 3x squared plus 2x minus 7, are my factors for this trinomial. So they're the things that you multiply together to give you the polynomial. And same with these two last binomials, x minus 2x, or x plus 2x minus 2. If I multiplied those together, I would get x squared minus 4. That means that those two binomials are factors of x squared minus 4. So now we've got a process that we're going to use here for factoring, and the first step that we're always going to do is we're going to factor out our greatest common factor. Now that could be a number, or it could be a variable, or it could be a number and a variable. After we get done factoring out our greatest common factor, we're going to then examine the number of terms in our remaining polynomials. We're going to look at it as 2 terms and then 3 terms. But let's back up and let's just practice factoring out our greatest common factor. Let's look at just the first step. So I have a trinomial here, 15x to the third minus 10x squared plus 5x. And I'm going to use this to demonstrate how to factor out a greatest common factor out of this polynomial. The first thing you're going to do is you're going to look at your coefficients, or your numbers, your whole numbers. 15, 10, and 5. What's the biggest number that will go into all 3 of those evenly if there is one? Well, I'm saying it's 5. So I'm going to factor 15 into 5 times 3, 10 into 5 times 2, and 5 into 5 times 1. Now that I've done my numbers, now I'm going to look at my variables. I have an x cubed, which means x times x times x, an x squared, which means x times x, and an x, whoa, how do I get this to stop? There we go. An x, which is just x. Now I'm going to look at this and I'm going to say, what do these 3 terms have in common? Well, they all have a 5. And I'm going to circle that. And they all have one x in common. So all 3 of these terms have a 5 and an x. That is my greatest common factor, and that is going to go out front. Everything else that I did not circle and put out front goes back into the polynomial. So I have 3x squared, because x times x is x squared, and I bring down my minus sign. And then I've got a 2x in this one. I'm going to bring that down. And then I've got a plus 1. So that is my factoring out my greatest common factor. Let's look at this next one. I've got 3x to the 4th minus x, or 12x. So first I'm going to look at only my numbers, 3 and 12. The biggest number that will go in both of those is 3. So I'm going to factor that into 3 times 1 and 3 times 4. Then I've got 4 x's there, because it's x to the 4th, and 1x there. Then I'm going to circle what I have in common. I have a 3 on both of them, and I have an x on both of them. I'm going to take that 3x and put it up front. Everything else that I didn't circle has to go back into my polynomial. So that's going to be x to the 3rd minus 4. Let's take a look at this next one. Now this next one, actually, we would factor out a greatest common factor if we were doing step one, but we are factoring out a greatest common factor. And so we're going to look at our numbers, which are 5 and 20. The biggest number that'll go into both of those is 5. So you're going to say 5 times 1 or 5 times 4. And then I've got x times x and x. So what those two terms have in common are a 5 and an x. That is my greatest common factor. It comes up front, 5x. Everything else that I did not circle goes back into a polynomial. So 1x minus 4. All right, hopefully you're starting to see how this works. Now this next one, I'm looking at my 2 and my 9. Greatest number that'll go into both of those evenly, there isn't one. So I'm going to just leave my 2 and my 9. And now I'm just going to look at my variables. I have 2 x's there and I have an x there. Well, the only thing these two terms have in common is an x. That is my greatest common factor. So I'm going to put that up front. Everything I didn't circle goes back in my polynomial. That is step one, factoring out a greatest common factor. All right, now, if you look back on your notes, it said step 2 is look at your remaining polynomial. And if you have 2 terms, you're going to look for a difference of squares. Well, what the heck is a difference of squares? And it is a binomial that follows a very specific pattern. And it is the first term is a perfect square. There is subtraction. And the second term is a perfect square. Well, what we mean by a perfect square is the product of a number times itself. So x squared is the product of x times x. So x squared is a perfect square. 4 can be the product of 2 times 2. So it is a perfect square. So when any time I have this pattern, I can factor that into x minus 2, x plus 2. So the square root of the first term and the square root of the second term subtracted and added. Now, if you multiplied those two factors together, you would get x squared minus 4. All right, let's take a look at our second one. It's x squared minus 9. Let's see if it follows our pattern. Well, we already said that x times x is x squared, so we know that's a perfect square. We know this is subtraction, and we know that 9, the square root of 9 is 3, so 3 times 3 gives us 9. So this could be a difference of squares. So I'm going to say x minus 3, x plus 3. So I take the square root of the first term minus the square root of the second term, square root of the first term plus the square root of the second term. All right, let's take a look at this next one. Now this is the one where honestly I should factor out 4 before I get started here, but I'm not going to, because we're just looking at difference of squares. So I know that 4 is a perfect square because it could be 2 times 2, and x squared is a perfect square. This is subtraction, and I know that 16 is a perfect square because it could be 4 times 4. So I could write this as a difference of squares, 2x minus 4 and 2x plus 4. Let's look at our very last one. Well, I know that 121 is a perfect square because it's 11 times 11. X squared, we've already said, is a perfect square, and 25, this is subtraction, and 25 is a perfect square, could be 5 times 5. So this could be written as difference of squares, 11x minus 5 and 11x plus 5. That is what difference of squares is. So let's kind of put these two things together. Let's look at this very first one. Factor 2x to the third minus 72x. Well, the first thing I'm going to do is I am going to factor out my greatest common factor. So I'm looking at 2 and 72, and I'm saying the greatest common factor between those two things is going to be 2. And then I've got 3 x's here, and I've got an x there. So what I have in common is 2x. That's my greatest common factor. Now I'm going to put everything else back into parentheses. I've got x squared minus 36. So step 2 says examine the number of terms. If there are 2 terms, look for difference of squares. Well, I do have 2 terms here. I've got x squared minus 36. I know that x squared is a perfect square. I know this is subtraction, and I know this is 36 is a perfect square. So I'm going to keep my greatest common factor, 2x, and then I'm going to factor the binomial into x minus 6, x plus 6. Look at the second one, 4x squared plus 100. Well, first I'm going to look at my numbers. I've got 4 and 100. I think my greatest common factor of those two is going to be 4. 4 and 1 and 4 and 25. And I've got x's there, but none on the other. So my greatest common factor is going to be 4. And then I end up with x squared plus 25. Well, I know that x squared is a perfect square, and I know 25 is a perfect square. But this is not subtraction, it is addition. So this cannot be difference of squares. So that is as factored as that is going to get. Let's take a look at this next one. We've got 200x squared minus 18. Well, between 200 and 18, I think that biggest number that'll go into both of those is 2. And the second term has no x's, so my greatest common factor in these 2 terms is 2. Everything else must go back into parentheses. Well, I know that 100 is a perfect square. I know that x squared is a perfect square. And I know that 9 is a perfect square. And I know this is subtraction. So I'm going to keep that greatest common factor of 2. And I'm going to factor this into 10x minus 3 and 10x plus 3. All right, let's take a look at our last one. There is no coefficient for x squared. So I can't factor out any greatest common factor out of these 2. So I'm just looking at x squared is a perfect square. I know that 81 is a perfect square. And I know this is subtraction. So I can say that this is going to be x minus 9 and x plus 9. So the first thing you do is factor out your greatest common factor. And then if you have a binomial left, you're looking for difference of squares. Sometimes you'll find it, sometimes you won't.